Another important set of principles related to visual perception are Gestalt groupings. These are principles of organization, basically perceptual organization, and include things like similarity, proximity, connectedness, including enclosure, continuity, and symmetry. So let's just run through a couple of quick examples. So we've got a field on the left of evenly spaced dots, and by just increasing the proximity, putting a little space, we see them as columns. It's that simple. And you do this all the time in practice. Think about the maps you've made for GIS. This is a beautiful example, isn't it? But I've often given feedback that the scale bar needs to be placed proximate to the map that it's measuring so that there is no ambiguity. So you would just fix this by changing the proximity basically and creating a group just by the organization. Another principle is similarity, and that's the idea of taking a consistent or uniform set of data and creating, by making similar groupings, rows, groups, or columns by changing the way they're encoded. The data sets are encoded. We do this when we're reading scatter plots, probably without even thinking about it. When we're reading scatter plots, we're using principles of both proximity and similarity. Clusters are proximate groups. How do you identify outliers? You look for the points that aren't proximate to the groups, right? And then similarity can be shape or color. We often will encode our data points or our observations using different kinds of shapes like triangles, circles, squares if we're working with a grayscale, or in this case, color. It helps us identify patterns between multiple variables. Okay, a third one is connection. Now you can see here that we've got those proximate groups, right? The top two rows are showing proximity, but the connection between them actually dominates. So the importance between the vertical groups becomes more important than the proximity makes the top two rows. And the same with similarity. Even though we've colored the middle two rows differently and we've created a grouping due to similarity, the connection actually trumps that. And then taking it one step further, enclosure dominates both connection, proximity, and similarity. It's feeling a little bit like rock, scissors, paper. Enclosure dominates connection. So the top two rows are related because they're proximate. There's a relationship to the items vertically because they're connected, and this vertical connection is stronger than the proximate relationship between the top two rows. But the most important relationship is with the dots enclosed in the circle that overrules the proximity and the connection. So think about these things with maps, right? Here we've just simply employed the idea of including the scale bar inside the frame for the top map. That's enclosure. There's no ambiguity here whatsoever which map this scale bar belongs to. Other ways we can apply connection and enclosure is, time series. We can connect the dots together and create a relationship between them. Enclosure, oftentimes you'll see, like in habitat analyses, you might have 95% of the points, and if we enclose them in a polygon, we're just creating stronger relationships between the data points. Tree maps and circle packing, which we've talked about before, these employ principles of proximity, similarity, and enclosure. Take a look at these and start challenging yourself when you're looking at plots. Try and ask yourself what kinds of these perception principles we're using when we organize data this way. Similarity, proximity, enclosure, things like that. Another one that's just, I think, good to be aware of is continuity. When you see an image like this, are you actually seeing this and this, or are you seeing this and this? Our eye wants to believe that we're seeing this. This makes sense to us. This does not. So it's, again, comes back to our inherent ways of thinking and taking in the natural world. connections are clear with smooth contours than they are for us to decode line drawings like this, or schematics where things are connected in a more networky way. And this comes into play when we look at plots that employ edge bundling, where we group things together to make it a little bit easier to take in. Symmetry is another one. Even though the brackets here are proximate, they don't relate to each other because they're not symmetrical. They aren't similar in shape either. So we tend to look at this and see 3 sets of brackets and not 4 groups or 4 independent, organized things. And applying symmetry, a really interesting looking plot is called a pyramid, a population pyramid, or a tornado chart. And it's basically, it's often used to compare like male and female populations. It's often a histogram just to show the difference in distribution. That's an application for symmetry. So this was a quick one. Now we've talked about, for perception into design principles, we've talked about pre-attention, how you notice things before you even think about them, and Gestalt principles that we can use to organize and structure on the page.